So as I said, thank you, Erin, for having me along today I'm just going to have a bit of a chat to you around the Ecosystem Health Monitoring Program and the current spatial temporal challenges that we're kind of seeing in the program at the moment, and some of the barriers that we have to resolving those. So the Ecosystem Health Monitoring Program is very much, its jurisdiction is Southeast Queensland, so we're at the southern end of Queensland, and the program has a series of members. So we have local governments, most of the local governments in the area are members. We also have the utilities, so that's the wastewater treatment plants and the drinking water suppliers. And it's an integrated monitoring and modelling program. We get a lot of our data, well, most of our data from Queensland government, so the DESGI, so including the stuff that Ryan spoke around earlier. And every year we get we collect all this data and we do a report card. So last Wednesday, we released a report card for Southeast Queensland where each of the catchments received a grade. And so this is kind of the big event of the year. And if you want to check it out, you can go see the website for that, more information around that. But what I wanted to talk to you around is I'll sort of quickly go through the structure of the program, and then from that it'll kind of help me sort of demonstrate to you the challenges that we're seeing. So broadly, as I said, it's an integrated monitoring, modelling program, but we're looking at all of, well, aquatic ecosystem health in Southeast Queensland, and that's kind of what it was designed to do. So, and I think this is really important when we think about the program, is that, you know, it was designed for a regional assessment of the pressures to the aquatic systems of Southeast Queensland, specifically point source, so that's your sewage treatment plant discharges, amongst others, and then also diffuse source, so that's all the stuff running off the land into the water. And what we have as part of the program to sort of make an assessment of that is we've separated here into freshwater, sort of the estuaries and the bay, but up in the freshwater catchment areas, we have a source catchment model where we look at the catchment loads. So that's the total nitrogen, total phosphorus sediment loads. And then we also have a stream health model, which looks at the in-stream health. And both of these have monitoring programs that inform those models that create this kind of annual assessment that we do. The other thing that so downstream in the estuarine regions and the bay, we have a receiving water quality model for most. We've got, how many estuaries do we have, Iris? we've got about 9 of them. So we've got, you know, 9 different estuarine models, and then we also have a couple of bay models to look at the receiving water quality, and we have monitoring programs that have been designed to inform those models. Having said that, though, we so at the moment, and the reason why this is quite a good moment to chat to you about this is this program's been going for about 20 years, and so we have this big long data set, and up until about 5 years ago it was just a monitoring program. We just did monitoring, and that's what we reported on. 5 years ago or 6 years ago, we kind of moved to this integrated modelling monitoring approach, and that was following a big review of the program. And every 5 years we try to do these reviews, and the point of the reviews are to look at, okay, well, what is it that our members want? Is the program delivering, answering the questions that they need answers to? And then the second one is, you know, what are the latest technologies, the innovations in modelling and monitoring that we can bring into the program? And so that's what happened kind of 5 years ago, where we moved to this kind of modelling monitoring approach, where the monitoring was revised to inform the models, and the models were designed to sort of answer these questions that we have around the pressures and the impacts on ecosystem health in Southeast Queensland. So what I thought I'll just go through kind of the freshwater, the different models and the monitoring that's sort of informing those, because that helps us kind of understand what are some of these kind of limitations and challenges. So in the freshwater, so this, I hope you can see here, and if I move about, is that really annoying for everyone online? So we've got 18 or so catchments in Southeast Queensland, and these are all the monitoring sites that we have at the moment. And you'll see that all the pink stars are the ones that we collect data from every year. And we only go out once a year to collect this monitoring, this particular, this is freshwater stream health. We'll just focus in on that in a minute. So that's we collect information on fish, macroinvertebrates, phys-chem parameters, and ecosystem processes, which is, you know, productivity, respiration. And that's only done once a year. We used to do it twice, we've dropped back to once. We used to do it at all these sites plus more, but we've dropped back to this kind of rotating monitoring design. And so, as I said, all years we do the pink ones, and then on rotation every 3 years we do the other ones, the different colours there. Why? So, what was that? Why? Why do we do it on rotation? Why have we dropped back? Combination of, well, we wanted to, funding, I'm just going to, funding is a big issue. Funding is a really big issue. Yeah, and so I think that was probably the bigger drive. But then also, to get to that point, they did an analysis of the data to identify which sites worked well monitoring them every year and which sites were okay to monitor every 3 years. And I'll have it, actually, I think the next slides kind of talk to the issues with that. So so what was I going to say here? So that informs this stream health model that we kind of talked about before. So what we do, so at each of these sites, if we have data for it, we report on that. If we don't have data for it, it's, you know, in an off year, then we use the stream health model scores and we report on that instead. What we're finding with the models, and this is the wonderful work of Erin Peterson, so this you can see here, this is the predicted and this is the measured results or scores for and these are the indices that we look at water quality, ecosystem processes, macroinvertebrates and fish. So they do quite a good job of, so the predictions are good, but you can see that they're slightly over predicting the, compared to the measured data. And there's some things that have sort of, we've identified as, you know, we could be doing better for the modelling to kind of address some of these issues. And also some of the parameters are really good, but, you know, ecosystem processes, for example, is not the predictive power there. It's probably not quite as high as some of the others. So there are some things we want to kind of look at. This is a very rough one that I pulled together just this morning. But when we're thinking about that, what are the issues there? So one of the things that Erin sort of highlighted is that the temporal sampling design assumptions have shifted. So when we picked those sites that we do every year, because we know the variability of those sites changes a lot, and so they need to be monitored every year. The ones that are done every 3 years, in the data that we used and set it up, though every 3 years that was kind of okay because the variability was quite low at those sites. But what we're finding now is that 5 years later, in fact, that variability has changed. And so those assumptions are kind of being eroded a little bit, and we're finding some of the least variable sites are so they're sampled less regularly. Anyway, so so we're thinking about potentially, you know, what are there alternative models that we could be using instead of these ones? So having ones that don't have, getting rid of that. The other issue we're finding is that the temporal autocorrelation is not there. So we're finding that when a site is monitored in a year, the next year the prediction doesn't take into account the data from the previous year. So if there's been a trend of the data going up or the trend of the data going down, the actual prediction doesn't take that into account. It's sort of going back to a mean rather than considering the trend. So there's no kind of autocorrelation in there. So there's some need to kind of consider that as well. So there's opportunities there within the stream health model. I'll sort of have a bit of a summary of the challenges and stuff at the end. I just talk through these other couple of models just to give you a bit more of a flavour of what sorts of things we're doing and some of the issues that are coming up. So this is the estuarine marine water quality component. So this is where we have a receiving water quality model. The sites, the data that goes into this is, all the orange and all the blue sites are our monitoring sites. They used to be monitored 12 times per year. We've dropped that back to 8 times per year. We don't focus so much. We focus mostly on the the months where we have lots of rainfall and the other months where it's less variable, we don't focus so much attention. Again, a funding thing, as well as the fact that we're using models now to make some of the predictions, so kind of relying on their estimates. So some of the issues that come up with that is, so when we have models, the model's doing a really good job, we use those assessments and when their predictive power is really high. But then if we find that it's not kind of meeting a few criteria that we have, we do fall back on just that base monitoring data. And I mean, the issue with that is, we used to do that in 12 months of data, now we're only doing that based on 8 months. And here's an example of, so this is dissolved oxygen over, this is the site numbers. Number 700 here is the downstream site, and this is Brisbane River. And 217 is the more upstream site. And you can see that there's in the measured, so this is the monitor data, there was a kind of DO Saeck around this area of the river, but the model data hasn't picked that up. Now, whether or not the model is doing a better job than the monitoring data, when it comes to talking to our stakeholders, if we were to show them that, they see this now as, this is the water quality objective, so that's their target. If we're under that water quality objective, that's a fail for them, and so that's a poor score. But if we were to go with the model data, it wouldn't have looked quite as bad as what it is. So making those decisions is actually quite we have our criteria that we base it on. We've got 5, have I? 3, okay. Okay, well then I might just skip across to so there's, I mean, with the program overall, there's sort of these 2 big challenges that are coming up as part of the existing review at the minute. There's the fact that the current design has some limitations that we do need to address. But I mean, it's suitable for what we're trying to do, which is a regional assessment of what's happening across the region. But there are some limitations we need to deal with. The second one is that our EHMP members would like us to be doing would like it to be doing more. So they have other objectives that they kind of want it to be doing, and particularly around a local scale assessment. So looking at assessment at a subcatchment, a reach, development site scale, where they can make decisions around what actions are needed and assess, the impact of any management actions that they've had. So the existing program can't do that because it's just, the scale's too high level. So some of the opportunities we talked about and kind of coming up is, can we improve that spatial resolution of the model predictions? So looking at that stream health model, also looking at the catchment pollutant loads model. But to do this, you need more data, and you need, good quality data. So there's these ideas around, could we go down a path of having something like a core and a satellite monitoring program design, so where you have a core set of data monitoring that's done consistently to keep that 20 data set going, and then a satellite monitoring program that is kind of meeting sub-regional needs. So whether it's, the needs of monitoring in the urban landscape, rural landscape, or the coastal landscape, all those needs and monitoring pressures are different, so you might have a different design, and could that potentially be an adaptive design as well, that kind of satellite roaming monitoring program. The other idea is that could we incorporate third-party data? So local governments have their own monitoring programs. Citizen science is one that we really want to go down. We want to be using that for various reasons, not just for improving the accuracy of our models, but also just to be engaging with the community. Compliance monitoring, there's a lot of compliance monitoring data out there as well. Could we bring that into it? But obviously that means lots of different data sets. So there's lots of barriers and risks to doing that. Bringing all this third-party data together is very complicated. There are, different methods, different frequencies. The sites aren't necessarily random. You often get these programs focused really in on like the poor areas, and that's why they're doing the monitoring. So that's where the monitoring is coming from. So that creates a whole lot of issues. You've got different indicators, even the site coming down to site mapping, but that's not, the site on one map might not be the same, might be the same on the other, but they don't appear to be, because there's no alignment there. The QA/QC issues and just the time-consuming nature of bringing it all together. The risks of an adaptive monitoring approach you know, it's a wonderful idea, but there are things that we need to kind of address before we can get there. Excuse me. You know, we may reduce the number of, it might cause us to reduce the number of sites that could be visited, because if, you know, if you're doing regular monitoring at the same sites, it's quite efficient and you can get to lots of sites. But as soon as you start kind of moving those around and going to new sites where you might not have been before, you lose some of that efficiency and you can't visit quite so many. You also lose that comparability if you're kind of moving those sites from one, because you know, we've got that long-term data set. If we start moving them around too much, we lose that kind of long-term comparability. And then there's the risk of losing, and so that risk losing the integrity of that long-term program. And then there's obviously, with bringing all this additional stuff in, we've got to consider funding costs and resourcing, data management, and even when we get to that, and is it enough? Like, this is, there's 46,000 kilometres of stream and SEQ. With all, you know, is it ever possible that we could get to an ability to look at the stream health of all of that full network? So so yeah, I guess that's just a summary of some of the things that we kind of see and some of the challenges. Sorry, I went very, very quickly, but I kind of just dumped it all on you guys, so you can kind of have a bit of a think about it.